Good morning all. Welcome to next lecture. Today we will discuss how to solve the system of linear equation in three variable case. See, if we already said that an equation with one variable require only one equation to have a unique solution. Similarly, the equation with the two variable require two equation to have a unique solution. So it is not surprising that the equation with the three variable require the system of three equation as well, especially to get a unique solution. So here we are going to discuss the system of linear equation with the three variable case. See what actually the system of linear equation with the three variable case. See, a system of linear equation with the three variable case involve the three equation, and each equation contain three variables. So the standard form of the linear system of three equation with the three variable are, see, ax plus by plus cz is equal to d1, ex plus fy plus gz is equal to d2, hx plus iy plus jz is equal to d3. So here, the a, b, c, E, F, G, H, I, J are the coefficients of the variable x, y, z. We have a three variable here. It is x, y, z. D1, D2, D3 are the constants. Consider one example of a system of linear equation with the three variable case. See, we have a three equation with the three variable also here. X plus 3y minus z is equal to 4. 2x plus y plus 2z is equal to 10. 3x minus y plus z is equal to 4. So we have a three equation here with the three unknown variables are x, y and z. So this is the system of linear equation with the three variable case. Now see, we have a different methods for solving the linear equation with the three variable case as well. We can use the elimination method and we can also have the substitution method. So there are certain other methods also, but we are going to discuss here only the elimination method and direct substitution method as well. So consider the first one, the elimination method. See, in this case, what we want to do? First, we want to select any two equation from the given three equation and solve for any one of the variable. So with the given three equation, we have to select any two pair. One pair, that is two equation can be selected and solve for one variable. After that, select the another pair and solve for the same variable, whichever you are going to eliminate in the first, which the same variable we are going to eliminate by selecting two another equations. After that, through this particular process, if you do this particular process, then we will get a two linear equation with the two unknown variable case. So once we get a two linear equation with the two variable case, then we can solve this particular equation by using 2 by 2 system, by using elimination method or direct substitution method to get the value of two variables. So once the value of two variables are get estimated, then finally we have to substitute the non-variable into any one of the original equation, so that we can also find out the missing variables as well. So in this way, we can solve the system of linear equation with a three variable case by using the elimination method. Consider one example so that it will be more clear. We will begin with a simple example to illustrate a general method of elimination. See, x plus 3y minus z is equal to 4. 2x plus y plus 2z is equal to 10. 3x minus y plus z is equal to 4. So we have a system of linear equation with three equation with three unknown variable x, y, z are the variable. So here the objective is to find the value of or the three numbers of x, y, z which satisfy this equation simultaneously. So here first we are going to consider first two equation and the variable x can be eliminated from the second equation by multiplying the first equation by 2. So multiplying the equation number 1 by 2 so that the coefficient of the variable x will be the same. So I am going to multiply here the equation number 1 by 2. So it will be 2x plus 6y minus 2z is equal to 8. Okay. Now I am going to subtract the equation number 2 from equation number 1. So here the equation number 2 is equal to 2x plus y plus 2z is equal to 10. Now in order to eliminate the x variable, we have to subtract. So I am putting here, it is minus sign here. So 2x will be cancelled out if you go for subtracting it. Then 6y minus y. So it will become 5y minus 2z minus 2z. Here we are putting subtracting. So it is minus 2z, it will become 4z minus 4z. Then 8 minus 10, it will become minus 2. So it is 6y minus y, which is equal to 5y minus 2 minus 2z, which will become minus 4z. 8 minus 10, which is equal to minus 2. So I am denoting here the equation as 4. So 5y minus 4z is equal to minus 2. Now consider another two equations. See, consider the equation number 1 and 3 so that we can eliminate the x variable, because we are eliminated here x variable. So the next step also we should eliminate the x variable. Then only we are able to get the simultaneous equation with a similar variable x, y and z, which we have already estimated here. So we are going to consider the equation number 1 and 3 here. So we can eliminate the variable x. See, here the coefficient of x is equal to 3, but here the coefficient of x is equal to 1. So that we want to multiply the equation number 1 into 3. So if you go for multiplying the equation number 1 into 3, it will become 3x plus 9y minus 3z is equal to 12. So I am writing here, that is 3x plus 9y minus 3z is equal to 4 into 3, which is equal to 12. Then the third equation, it is 3x minus y plus z is equal to 4. So in order to eliminate the x variable x, we have to subtract both equation. So here see, 3x will be cancelled out. 9y minus y. So minus y will become plus, so it will become 10y minus 3z minus z, because we are subtracting here. So minus 3z minus z, which is equal to minus 4z, 12 minus 4, which is equal to 8. So we have the equation number 5 here, that is 10y minus 4z, 10y minus 4z, which is equal to 8. So now we have the two simultaneous equation number 4 and equation number 5. So we have a two simultaneous equation with the two variable. So here it is 5y minus 4z is equal to minus 2, that is equation number 4. And 10y minus 4z is equal to 8, that is equation number 5. So we can use either the elimination method or direct substitution method. Here we are going to use the elimination method. So now we can eliminate the y here variable y. See, by multiplying equation number 4 into 2 so that we can eliminate the variable y. See, so that here it is minus sign, so I am not going to make it a confusion for elimination of z. I am going to multiply here the equation number 4 into 2, so it will become, see, 2 into 5y, which is equal to 10y minus 8z is equal to minus 4. Then the fifth equation, that is 10y minus 4z is equal to 8. So I am going to subtract here so that we can eliminate the variable y here. So 10y, if you go for subtracting it, then it will be cancelled out. Minus 8z minus 4z. So minus will become plus. So minus 8 plus 4z will become minus 4z, which is equal to minus 4 minus 8, which is equal to minus 12. So now we can solve for z by dividing the both side of the equation by minus 4. So z is equal to minus 12 divided by minus 4, which is equal to 3. So here the value of z is equal to 3. So if z is equal to 3, then we can substitute the value of z is equal to in equation number 4 or 5 so that we can identify the value of y as well. See here, I am considering here equation number 4, that is 5y minus 4z is equal to minus 2. So substituting here the value of z is equal to 3, 5y minus 4z, that is 3 is equal to minus 2. So 5y is equal to, it is minus 12. So I am taking into the right hand side of the equation, so it will become plus 12. So it is minus 2 plus 12. Dividing the both side of the equation by 5, we can isolate the y. So 5y is equal to here, it is, it is minus 2 plus 12, which is equal to 10. Dividing both side of the equation by 5, y is equal to 10 divided by 5, which is equal to 2. So we received the value of z is equal to 3, y is equal to 2. Now there is one variable is remaining, that is missing, that is variable x. We want to find out the value for the variable x as well. So in order to find out the variable x, we are going to substitute the z is equal to 3 and y is equal to 2 in any of the first three equations. For example, I am going to substitute here y is equal to 2 and z is equal to 3 in the equation number 1. See, equation number 1 is equal to x plus 3y minus z is equal to 4. So here substituting the value of y is equal to 2 and z is equal to 3, this will become x plus 3 into 2 minus z is equal to 3, which is equal to 4. So it will become x plus 6 minus 3 is equal to 4. So x is equal to, it is 4 minus 3, which is equal to 1. So here the value of x is equal to 1, z is equal to 1. So here the value of x is equal to 1, y is equal to 2 and z is equal to 3. In this way, we can give the solution to the system of linear equation with a 3 variable case by using the elimination method. Consider one more example so that it will be more clear. See, we have another equation, that is 4x plus y plus 3z is equal to 8 minus 2x plus 5y plus z is equal to 4, 3x plus 2y plus 4z is equal to 9. So we have a system of linear equation with the 3 variable and 3 equation we have. So we want to eliminate here the variable x from the second equation, so that we want to multiply by 2 and add to the equation 1. So that, see here, consider the first two equation. The coefficient of x is equal to 4, here the coefficient of x is equal to minus 2. So I am going to multiply the equation number 2 into 2 so that coefficient will be same, that is 4. So multiplying the equation number 2 by 2, it will become, see, this is the first equation as it is I am written here. Then the second equation will become, see, minus 2x into 2, which is minus 4x, plus 5 into 2, that is 10y, plus 2z is equal to 2 into 4, which is equal to 8. Now see here, we have the same coefficient, that is 4, here also, here it is minus 4. So we can eliminate here the variable x by adding the two equations. So if you go for adding the two equations, see, 4x and plus 4x and minus 4x will be cancelled out. Y, 1y plus 10y, which will become 11y. Then 3z plus 2z, which will become 5z, which is equal to 8 plus 8, which is 16. I am giving the number, it is equation number 4. Now, I am considering the equation number 1 and 3 so that we can eliminate the x variable again here, because we are already eliminated the variable x here, so that the next step also we should eliminate the variable x. So here we are going to consider the equation number 1 and 3, but the coefficient of x, first equation, that is coefficient of x is equal to 4 and x is equal to, here it is 3. So what we want to do, we want to multiply the both equation by equation 1 by 3 and equation 3 by 4, so that we will get the same coefficient, which is equal to 12. So see here, I am going to multiply the equation number 1 into 3, so it will become 1 into 3, that is 3 into 4x, which is equal to 12x, plus 3 into y, which is equal to 3y, plus 3 into 3z, which is equal to 9z, which is equal to 3 into 8, which is 24. And similarly, I am going to consider the equation number 3 and multiplying with 4. So again it will become, see, it is 12x plus 8y plus 16z, which is equal to 36. So now the coefficient of the x, variable x, is equal to same. So in order to eliminate the 12x, see, we are going to subtract it. So I am putting here minus sign so that we can subtract it. So here 12x will be cancelled out. If you go for subtracting, 12x and 12x will be cancelled out. 3y minus 8y, which will become minus 5y. 9z minus 16z, which is equal to minus 7z. Then 24 minus 36, which is equal to 12. So I am putting here, this is the equation number 5. So see here, we have a simultaneous equation, that is equation number 4, which is 11y plus 5z is equal to 16 minus 5 minus 7z is equal to 12. This is the equation number 5. So we have a simultaneous equation with 2 variable and 2 unknown variable and 2 equation as well. So that we can solve this equation either by using the elimination method or by using the direct substitution method. Here we are going to use the elimination method. See here, we are here going to eliminate the variable y. So that we are going to multiply the equation number 4 by 5 and equation number 5 into 11. So that we will get a same coefficient for the y. So multiplying equation number 4 into 5, see, it will become 11 into 5, which is equal to 55y plus 25z is equal to 16 into 5, which is equal to 80. Similarly, the equation number 5 I am going to multiply with 11 so that we will get a same coefficient of 55. So equation number 5 into 11, it will be equal to minus 55y minus 77z, which is equal to minus 132. Now see, we have the same coefficient of y, 55 and 55. I am going to add up these two equations so that I can cancel out the y variable. So see here, if you go for adding up, 55y minus 55y will be cancelled out. Then 25z plus 25z minus 77z, which is equal to 52 minus 52z, because here the sign is minus, so it will be minus 52z. 80 minus 132, which is equal to minus 52. So now z is equal to, see, dividing the both side of the equation by minus 52, it will become minus 52 divided by minus 52, which is equal to 1. So z is equal to 1. When z is equal to 1, now we can substitute the value of z is equal to 1 in any one of these equation number 4 or equation number 5. Now see here, z is equal to 1, we are going to substitute in the equation number 4. See, equation number 4, here it is 11y plus 5z, which is equal to 16. So here z is equal to 1, I am substituting here, so it will become 11y plus 5 into 1, instead of z I am putting 1, which is equal to 16. So 11y plus 5 is equal to 16. Then 11y is equal to 16 minus 5, which is equal to 11. Dividing both sides of the equation by 11. So y is equal to 11 divided by 11. So y is equal to, again it is come out with 1. So z is equal to 1, y is equal to 1. Now we have z is equal to 1 and y is equal to 1. We can substitute these values into either the equation number 1 or equation number 2 or equation number 3. Here we are going to substitute these values on the equation number 1. See, equation number 1 is 4x plus y plus 3z is equal to 8. So substituting here, see, 4x plus y is equal to 1 plus 3 into z is equal to 1. So we have 4x plus 1 into, plus 3 into 1, which is equal to 8. So we have 4x plus 1 plus 3, which is equal to 4, is equal to 8. 4x is equal to 8 minus 4, which is equal to 4. Dividing the both side of the equation by using 4, we will get, x is equal to 4 divided by 4, which is equal to 1. See here, the value of x is equal to 1, value of y is equal to 1, and value of z is equal to 1. So this is the solution for the given system of linear equation with the 3 unknown variable case. Now, we are going to discuss the direct substitution method. Whatever we discussed till now, it was the elimination method. Now, how can we find the solution to the system of linear equation by using the direct substitution method? See, the direct substitution method is a technique which actually used to solve the system of equation, including those with 3 variables as well, which we are going to discuss here. See, in this method, we solve the one equation for one variable and then substitute that particular expression for that variable into another equation. So this procedure repeat until all the variables are eliminated except for one, and allowing you to solve that particular variable. We have to continue to solve the resulting system of equation until we find the value for all the given variable in the system of linear equation. So we are going to use the direct substitution method and see how we can find the solution to the system of linear equation with the 3 variable case by using direct substitution method. See, consider one example. X plus 6y minus z is equal to 10, 2x plus 3y plus 3z is equal to 17, 3x minus 3y minus 2z is equal to minus 9. See, we are going to solve any one of the equation for one variable. For example, we are going to consider the equation number 1. See, equation number 1, that is x plus 6y minus z is equal to 10. See, I am solving for x, so it will become 10. Taking the 6y into the right hand side of the equation, so it will become minus 6y, minus z also taking into the right hand side of the equation, so it will become plus z. So we are converted in the form of isolating for x. So x is equal to 10 minus 6y plus z. I am denoting it, it is equation number 4. Now I am going to substitute this equation number 4, that is value of x expression, into the equation number 2. So if you substitute the value in the equation number 2, then it will become, see, 2 into, instead of x, I am substituting 10 minus 6y plus z. Then what is remaining? 3y plus 3z, which is equal to 17. Now we can open the bracket by multiplying these two terms. See here, 2 into 10, which is equal to 20, 2 into minus 6y, which is equal to 12y, plus 2 into z, which is 2z. Then what is remaining? 3y plus 3z, which is equal to 17. Now we are going to simplify this equation. See, minus 12y plus 3y, which is equal to minus 9y, 2z plus 3z, which is equal to 5z. Then we have 17. Here it is minus plus 20, which will become minus 20 when you take it to the right hand side of the equation. So it is minus 3. I am denoting this is equation number 5. In the similar way, we are also going to substitute the value of x is equal to 10 minus 6y plus z on the equation number 3 as well. So the equation number 3, which is equal to 3x minus 3y minus 2z is equal to minus 9. So I am substituting instead of x, which is 3 into 10 minus 6y plus z minus 3y minus 2z, which is equal to minus 9. Here we can open the bracket by multiplying 3 into all these terms. So it will become 3 into 10, which is equal to 30, 3 into minus 6y, which is equal to 18y, then 3 into z, which is plus 3z. Then what is remaining here? It is minus 3y minus 2z, which is equal to minus 9. If you go for simplifying it, minus 18y minus 3y, which is equal to minus 21y, then plus 3z minus 2z, which will become, z, then minus 9 minus 30, which will become minus 39. I am denoting here it is equation number 6. So see here, we have the equation number 5 and equation number 6, which having the simultaneous equation with the two same variable, that is y and z here. So we are now considering the system of linear equation with the two variable case, that is equation number 5, which is minus 9y plus 5z is equal to minus 3, minus 21y plus z is equal to minus 39, that is equation number 6. Now we are going to solve these two equations simultaneously. We are going to eliminate one variable. Say here we are going to eliminate the z, the variable z. If you go for multiplying the equation number 6 by 5, so that coefficient of z will be similar. So I am going to multiply the equation number 6 by 5. So it will become, the sixth equation will become 21 into 5, which is minus 105y plus 5z, which is equal to 5 into minus 39, which is equal to minus 195. So here, now we are going to consider the equation number 5 and 7. See, it is 5 is minus 9 plus 5z is equal to minus 3. Then this 5 plus 5z is equal to minus 195. So here see the coefficient of z is same, that is 5. So we can eliminate this z by subtracting the equation number 7 from the equation number 5. So it will become, subtract the equation number 7 from 5, so it will become, see, minus 9y plus 5z minus 105y plus 5z, which is equal to minus 3 minus 195. So here I am going to open the bracket. So here minus 9 plus 5z. See here minus into minus 105, which will become plus 105. Then minus into plus 5z, which will become minus 5z, which is equal to minus 3 minus into minus, which will become plus 195. So we can go for simplifying it. See, it is plus 5z and minus 5z will be cancelled out. Then minus 9y plus 105y, which is equal to 96y, minus 3 plus 195, which is equal to plus 192. By dividing the 96, both sides of the equation by 96, by using the 96, which will become 192 divided by 96, which is equal to 2. So here the value of y is equal to 2. When the value of one variable, that is y, is equal to 2, then we can substitute this value in the any one of the equation, that is equation number 5 or equation number 6. See, we are going to substitute here the value of y is equal to 2 in equation number 5. It will become, see, minus 9y, this is the equation number 5, that is minus 9y plus 5z is equal to minus 3. Now instead of y, I am going to substitute it is 2. So it will become minus 9 into 2 plus 5z, which is equal to minus 3, minus 9 into 2, which is minus 18, plus 5z, which is equal to minus 3. I am going to isolate the 5z here. By taking the minus 18 into the right hand side of the equation, it will become plus 18. So minus 3 plus 18, 5z is equal to, it is 15. Dividing the both side of the equation by 5, see, it will become z is equal to 15 divided by 5, which is equal to 3. So we have two values, that is y is equal to 2, z is equal to 3. Now see, we are going to substitute the value of y is equal to 2 and z is equal to 3 in the equation number 1. See, equation number 1 is equal to x plus 6y minus z is equal to 10. Then substituting y is equal to 2 and z is equal to 3 here, it will become, see, x plus 6 into 2, 6y, it is 6 into 2 minus z, that is minus 3, which is equal to 10. So it will become x plus 6 into 2, which is 12, minus 3, which is 10. If you go for simplifying it, x is equal to 10 minus 12 plus 3, which is equal to 1. It is 13 minus 12, which is equal to 1. So we have the value of x is equal to 1, value of y is equal to 2, and the value of z is equal to 3. So this is the answer for the system of linear equation with 3 unknown variable cases by using direct substitution method. I hope it is clear to you. Now see, we are going to consider the graphing a system of linear equation with 3 unknown variable case. See here, the graphing a system of linear equation with 3 unknown variable case involves, see, representing the equation in 3-dimensional space. It is a 3-dimensional space. It is not a Cartesian coordinate system. Each equation corresponds to a plane, and the point of the intersection of these plane represent the solution to the system. So it will be in the form of a plane, Cartesian plane. So for the system of 2 equation, we have used the space of 2 dimension, that is x coordinate and y coordinate, especially in the case of when we have a 2 variable case. We need a space of 3 dimension, and that is x, y, z. That is, we are considering here 3 unknown variable. So we have a x, y, z coordinates. So the geometry of the solution to the system of linear equation with three variable, unknown variable can visualized in, it is three-dimensional space. It is very difficult to represent. See, the solution corresponding to the point where the equations on the graph intersect. Each equation represents a plane. It will be a plane. So the intersection of these plane form the line or point. Then what we want to do? Depending upon the relationship between the equation, the three-dimensional space, the plane is uniquely defined by a particular point and a normal vector perpendicular to that particular plane. See, it's although very difficult. It is very difficult to do, difficult to find out the solution to the, system of linear equation, or it is graphing of the linear equation with the three variable case, especially by using hand. We will try to draw it and discuss the possible by geometric design for the system of three linear equation with the three variable case, that is x, y and z. See here, we will have a unique solution when we have a point of intersection of these three planes. Suppose you have a system of three linear equation in three variable case, and each equation represent a plane in the three-dimensional space. We have a three-dimensional space. The set of solution to each equation form a particular plane. I will show it so that it will be more clear. When you have a three plane corresponding to the system of three linear equation, then the solution of the system is the point where all the three plane will be intersect. If the three plane intersect at the single point, if the three planes are intersecting at a single point, then we have a unique solution to the system. Then we have a unique system into this system. See, if we have three planes that intersect into a single point, then we have a unique solution. Otherwise, there is no unique solution. So this point represent, x, y, z that satisfy all the three equations that satisfy simultaneously. See, we can graph it by using, one pick here. See, this will be the point of intersection. See, in this intersection form, this is a plane, this is one variable, this is another variable, another equation, this is another equation. So in this particular intersection form, a single point, see here, this is the particular point. At this particular point, three planes are intersecting at a single point, and it means that there is only one set of value for each variable that satisfy three equations. See, the three equations are represented in terms of three plane, and these three planes are intersecting only at a single point or single value or one set of value for the variable that satisfy all three equations, and therefore we can say that we have a unique solution exists. We will have a unique solution, and thus we have a single intersection point here, and therefore we have a unique solution in this particular case. Now there is another possibility, that is no solution when we have a parallel plane. If the planes are parallel, then we will not have any particular solution. See, if you have a system of three linear equations with three variable case and plane are represented by, these equations are parallel. These equations are representing as a parallel. That means there is no point of intersection between the plane. Then this situation implies that there is no value for the variable that satisfy all the three equations simultaneously. See, we can represent it by using the diagram, so that, or we can represent by using the space, three-dimensional space, so that it will be clear. See, it will be look like this. Three equations are represented by three planes. All these three planes are parallel to each other. So geometrically, if the planes are parallel, then these planes are never intersect. These planes are never intersecting, and the system of the equation have no common solution in this particular case. So the planes are parallel. We doesn't have no common solution. In other words, we can say that, see, there is no value for the variable that simultaneously satisfy all the three equations. So here the system will not have any particular solution when we have a parallel plane. Now, even if the planes are not parallel, for example, this is the case. It is not parallel, but it is intersecting. But three spaces are, or three spaces are not intersecting. Here intersecting only 2, here is also intersecting 2, here also intersecting 2. See, there may be another scenario, this one, where 3 planes are might not intersecting, even if 3 planes are not parallel. This is not a parallel, but at the same time it is intersecting by 2 spaces. In this case also there is no common shared by all the 3 planes. See here, we can't find the 3 planes which are intersecting here. We are only 2 points are intersecting, either here or here. So here 3 planes are not intersecting each other. So resulting the system having no solution in this case also. Now consider the another solution. See, if the equations are coincide or it is overlap, then in this particular case we have a 3-dimensional space. See, we have a 3 linear equation that is coincide or overlap. So in this case the 3-dimensional space, it means that we have infinitely many points that satisfy all the 3 equations simultaneously. See, we can draw the graph. See here, it will be look like this. See this one, the red one, and also we have blue one, and also this is dark one. So here see, 3 are intersecting each other from this particular point to this particular point. See, we have infinitely many solutions exist between these particular ends. So this is the graph of the the infinite solution when the linear equations are overlapping in the 3-dimensional space. So in this case also, see, the system is what we can say, it is dependent. In this case the system is dependent and the common solution is lies along a line. And the system is infinitely many solution here. See, the solution lies from this particular point to this particular point. So we have infinitely many solutions are existing here. And the plane are overlap along with this particular line, and any point on this particular line, this is valid solution to the system. So geometrically, the plane is overlapping along the line can be visualized having infinite point in common. So mathematically we can say that the system is consistent and dependent, and indicating that there are infinitely many solutions are exist. And this situation arises when the system of equation does not provide enough independent information. The system does not provide enough independent information to uniquely determine any single solution. Rather, we have infinite solutions are available here. So in this way we can represent the linear equation with the 3 variable case by using the spaces. So let me conclude here. In this lecture we actually discussed the system of linear equation in which there are 3 equations and 3 variable unknown variables which are called simultaneous equation with the 3 variable model. And I hope it is clear to you. In the next lecture we will discuss the applications of linear equation with 1 variable, with 2 variable and 3 variable in economics. We will see in the next lecture. Thank you.